Yeah. Hello guys. Good morning to one and all. So today we are going to see about webinar on applying convolutional neural network in deep learning. Okay. So before I am going to this session, I need to introduce myself. My name is Kamalesh. I am from Pantech solution. I am working under projects of data analytics like machine learning, deep learning, NLP. So today I am going to take about how today I will teach you how we can implement convolutional neural network in using deep learning. Okay, so before we are going to this session, I need to tell thanks to Kalasalingam Institute of Technology, Krishna Koil. Okay, so this program is organized by Department of Electronic and Communication Engineering and Department of Computer Science and Engineering. Okay, in association with Pantech e-learning. Okay, so thanks to Kalasalingam Institute of Technology and both the department ECE and Computer Science Engineering, and I have to give special thanks to coordinators and convener. Okay, so thanks for coordinators and convener. So they mentioned two names are mentioned above. So thanks to the HOD of ECE department and CSE department and principal. Okay, thank you. So let's we move on to neural network. Okay, deep neural network. So these are the table of contents we are covering today's session. Introduction to CNN and few definition how we can use CNN, how we want to use some pre-processing and all. But what is CNN? I need to just tell you. Before we need to go to CNN, I need to tell you what is deep learning. Okay, so deep learning is nothing but it's a subset of AI. Okay, so if you want to train machine learning type of algorithm, we need some features. Okay, so like if you take one pencil, means the pencil have some attributes like needle, wooden, and colors, and size, shape, like that some attributes will be there. Okay, based on those attributes I will train the machine learning algorithms. But if it is a deep learning algorithm, uh, I won't take any features. Okay, I will give directly uh, images to the data, and I will train the algorithm. Okay, so this is the main thing we are doing in deep learning. Okay, so before we are going to deep learning, I have to tell you what is CNN. Okay, convolutional neural network. Okay, so convolutional neural network is nothing but it's a feed forward neural network. It's like a feed forward neural network, but it's not a fully connected. It's a not fully connected layer like a artificial neural network. It's without fully connected layer. For example, before this session I posted one simple deep artificial neural network algorithm, how to deploy simple artificial neural network algorithm. In those videos, which dataset I am using, same dataset only I am using for here also. Okay, so if you are new to convolutional neural network, you can see those videos. Some basics also I showed in those videos, how to train and how to test, and some basics are there. It's easy to understandable. After this webinar I will upload those link in my description. You can just click that link and just watch those videos also. Okay, so convolutional neural network is nothing but it's mainly used to analyzing an images. Okay, mainly used to analyzing in images. Okay, so if your data set in the form of any text or any integer or any numerical value, we can easily convert those data into an machine readable, and then after those algorithm understandable, convert them into algorithm understandable, and then train the algorithm and test the algorithm. But if your data set in the form of image, okay, image means nothing but it's a multi-dimensional matrix. Okay, for example, if you take an one 28 into 28 pixel, means it is not a it's far as it is a pixel, but it's the background of that picture is consisting of only an matrix. Okay, 28 into 28 matrix. Okay, they consisting of RGB, red, green, blue colors. Okay, So based on those multi-dimensional matrix, I need to train those algorithms. Okay. So what is CNN? Okay, CNN is nothing but, I already told to you, it's a computer vision. That is, it's mostly used for computer vision type of. Computer vision is nothing but it's one module available in Python just to view your cameras. Okay, just for to access your cameras. Through cameras, it's, for example, I train my face image to the algorithm. After I am training the face image to the algorithm, I need to check whether it's trained properly or not. Means I need to give as an input. Those input will be given through my camera. So the camera will be capture my face and then it will be give the output. Okay. So this is like what happening in computer vision. Okay. So CNN is used for many way, like face recognition and image classification and etc. Okay, it's similar to the neural network only, but it's not a neural network because it's not a fully connected layer. Because if you take a neural network, means it's a fully connected layer. Here we are not using any fully connected layer. Okay, so like same thing only in neural network also we have white, bias and some of the input data is there. So like same thing only here also we need to create, but it's not a fully connected layer. Okay, so why we are using a CNN? Okay, what is the use? Why should we are using CNN? Okay, so for example, I am taking a neural network algorithm. Okay, so I am giving one image to the neural network algorithm like 28 into 28 megapixel. Okay, so I am giving an images to the neural network algorithm. What is the 28 into 28 means? I will get 784. Okay, so 784 neurons we need to give an input data. Okay, neuron is nothing but it's a to get an input data from the data set. Okay, so using 784 neurons, I am transferring my input data and then I am passing those those input data to the next neurons, that is next hidden layers. Okay, so hidden layer will be access those input data and then finalize one output, then it will be give the result. Okay, but here I am having only few number of neurons, so we can access we can do with the neural network itself. But normally if you take 28 into 28 megapixel means nowadays it's not possible. If you download some images through online also, its pixel size is more. Okay, like 128 megapixel or nowadays 64 megapixel or more number of megapixel is there. Okay, so if it is a megapixel is increased, the input layers also increase like 1000 or more than 1500 or 2000, 3000. Okay, so if it is a 3000, 4000 megapixels there, if you want to compute those megapixel into an one neural network is can't possible because we need more number of neurons. Okay, so for that purpose we are using CNN. Okay, so CNN is nothing but, for example, if I take a image of 224 into 224, 3 layers is nothing but RGB. 224 into 224, then into 3 means RGB, red, green, blue. That is one color image. Okay, I will take on color image means I will be get an input layer as using those picture. I will take some important data using some filtering methods, and I will pass those important, that is not an important data, in some future data, some important futures data in those image, and I pass it into the convolution layer and maximum pooling layer and softmax. Okay, so that is what I am telling. If you are having a more number of data set with megapixel high, you need to use convolution neural network. Then only it will be easy to run the code and easy to execute the code, and our output also will be more accurate when compared to neural network algorithm. Okay, so some of the definitions like image. Okay, so normally if you take image is with color. Okay, so what are the colors? If you take one colorful image, one color image means they have totally 3 channels. Okay, 3 channels is nothing but red, green and blue. That is, you already know about this RGB. Okay, so red, green and blue. Okay, so if it is 28 into 28 megapixel, my output in image process we represent those images is equal to 28 into 28 into 3 is nothing but 3 channels. Okay, and then edge detection. So I already told you we need to take some important data in my image. Okay, because we don't need to give more number of neurons as an input. We need to give as an input, but it's a less number of neurons. Okay, so for that purpose you need to detect some edge. Okay, for example, if you have an one tree image, in those tree image the background is nothing, only blue color or green color, we need to detect some edge, that is we need to detect some edge of those trees. Okay, so we need to do some edge detection method. Okay, so like for example here I am having one images, that is grayscale image. Okay, so grayscale image is nothing but starting is white and then ending is black. Sorry, that is 0 to 255 range. Okay, grayscale image is nothing but it's look like a black and white image, but not a black and white image. From it's a range, having a range from 0 to 255. Okay, so what I will do means I will take one image. That image should be an 1 2 3 4 5 6 into 6 images is there. Okay, I need to do what I will do means I want to detect the edge detection, so I will multiply those image into 3 into 3 matrix. Okay, so what I will get a output means I will get the output of 4 into 4 matrix. Okay, that is grayscale image and white scale image. Okay, so that is the uses of edge detection. Okay, so here I am showing a simple architecture of convolution neural network. Okay, so here you can see first I have one photo, that photo having the photo of car. Okay, so I am taking and some future data in that photo. Future data is nothing but I am taking some important data in that photo, input photo. Okay, so after I am taking using convolution layer, I am taking some important data. In those convolution layer I am doing some pooling method. Pooling method is nothing but if I have a matrix of 28 into 28 matrix, I will reduce those matrix into 5 into 5 or 6 into 6, like that I will reduce those matrix. That is called pooling. Okay, so after that I am doing those pooling method. Next I will move on to again convolution and pooling, that is again from starting convolution and pooling. Okay, so after I am doing like those steps again and again, I will be get on final output. Okay, I will be get on final data. Okay, using those data I will be flatten the output data. Okay, flatten is nothing but I will convert those matrix into vector form. Okay, I'm converting those data into vectorized form, but vectorized form will be connected by fully connected layers only. Okay, so here what is the meaning of fully connected layer means I have an input layer 2 and I have an hidden layer 5. Okay, so those two input layer will be connected with each 5 hidden layer, that is called fully connected layer. Okay, if it is not connected with each 5 layer, that is called not fully connected layer. Okay, so here I am using after flatten fully connected layer. So using fully connected layer I am converting those data into vectorized form. Okay, after that I am using some functions like softmax to finalize the value, binary value, whether it's a 0 or 1, whether it's a truck or car or van, like that. Okay, so this is the simple architecture we are for convolution neural network. Okay, so next one is nothing but dataset description. Okay, what type of dataset here I am using, I want to tell to you, because then only you guys will understand. Okay, like this. So that's why I am showing you dataset description. You need to just go through the description. Okay, so here I am having some data, that dataset in the form of grayscale image. Okay, I already told you grayscale image is nothing but 0 to 255 range. Okay, so here I am having some dataset. Dataset is nothing but fashion. Okay, fashion minist dataset. So these dataset normally it's available in your default deep learning package. Okay, so here today session I am using the package of Keras and TensorFlow. It's not about Keras and TensorFlow I will tell to you. Okay, so those in those Keras it's defaultly available those dataset. You just want to import those dataset to your coding part. Okay, so here I am having a data that is 28 into 28 image size, and then I have a label description. Okay, label is nothing but output of the output in the binary value. For example, 0 means t-shirt, 1 means trouser, 2 means pullover, 3 means dress. Okay, so I am having a data and I am having an output in my data set. Okay, so using those data set I want to train the algorithm. Okay, so to train the algorithm I have 16,028 into 28 images, that is grayscale images of 10 fashion categories. Okay, you have to understand those data set. I have a data set of, to train the data set I have 16,000 images. That images is 28 into 28 grayscale value images, that is all the 16,000 images will be in those pixel value, and then those all the 16,000 image pixel value will be have an output value, that is 10 fashion categories. Okay, and then I having a test data, that is 10,000 test data. Okay, so we need to find, after I am training those 16,000 images to the algorithm, we need to test the images. Okay, for that purpose I am giving those 10,000 images to the algorithm, and algorithm will give the label. Okay, whether it's a t-shirt or whether it's a trouser in the numerical form 0 1 2 3. Okay, this is the what I have to tell to you about dataset description. Okay, so dataset, before you are going to code any algorithms like machine learning or deep learning, you need to analyze the data set. Okay, that is the important thing in coding. Okay, during coding time. Okay, so now I want to do those data set for our convolution neural network, but what I have to do means, here I need to tell some of the layers. I just tell the architecture of the data set, architecture of a simple architecture of the convolution neural network, but what is the use of convolution, what is the use of pooling, okay, what is the use of flatten, and what is the use of softmax, I need to tell line by line. Okay, so I will tell line by line. So here you can see I have a input layer and convolution layer, that is plus ReLU is the activation function, and then pooling layer, fully connected layer, that is short form FC layer, and softmax logistic layer, and then output layer. Okay, so input layer is nothing but we already know the dimension of the images. Okay, each image will be a 28 into 28 grayscale image. Okay, so if I multiple this 28 into 28 in image, I will be get a 784. Okay, so 784 is my input data. Okay, that is input. You need to give an input layer as a 784 neurons. Okay, after that what I will do means, I will convert those input into an feeding. I want to feeding those 784 input into one dimensional shape. So I am multiply with 1. Okay, so I will be get an 784 comma 1 m. Okay, so this is my input layer. Okay, input layer is nothing but just I am passing my data to the neurons. Okay, so after that what it will be happen. Okay, so for example I am telling, here I am having some features of the you can take like a t-shirts or pant or shoe, anything, any one fashion article. Okay, so for example I am taking as a t-shirt. Okay, for t-shirt I am taking 3 important features. Okay, here I am having a input volume, 3 input volume. In those input volume represent t-shirt. Okay, so these are the important volume for to get a t-shirt. For example I am telling. Okay, so here I am getting a t-shirt input. I need to, here I have a more number of matrix. Okay, you can see the first volume and second volume and third volume, we have a more number of matrix. Okay, so what convolution neural network will be do means it will be converted into a 3 into 3 column. Okay, so first data will be converted into 3 into 3 column, second data will be converted into 3 into column using filter. Okay, filter is nothing but you need to find the important data in those input volume, and then I will convert it into a 3 into 3 column. Okay, after I am converting into 3 into 3 column, I want to again I will represent, I want to predict the both zeros and one bias value. Okay, so next I will move on to zeros. Okay, so what is the output of zeros? Okay, then I will be get a final output with the 3 matrix. Okay, 3 into 3 matrix. So here you can see I am giving a first input value as a mass number of input value, but finally I am getting a only 2 input value. Okay, so that is the use of convolution neural network. It will be take some important features those input data. Okay, so like this. Okay, so first I am having, I am taking a first part. In those first part I am multiplying into an 1k value. So I into k, I am getting an output equal to 4. Okay, so this is the final result of those input data, those number of mass data. I am getting an output 4. Okay, so that is the use of convolution layer. Okay, when you comes to pooling layer, I am having an two types. Okay, one is maximum pooling, one is average pooling. Okay, so maximum pooling is nothing but whether the data should be is greater than 0 or equal to 0. Okay, that is the maximum pooling. Okay, average pooling is less than 0. Okay, so here you can take, I am in first matrix I am having 29, 15, 0, 100. Okay, so in those maximum pooling is maximum value is 100, so I am taking it as a 0 into 0 column as a 100. So again I am taking a second one in those 184 maximum. So I am taking a maximum value into 2 into 2 matrix as maximum pooling. In average pooling I am taking an average value into 2 into 2 matrix. Okay, so that is the use of pooling layers. Okay, so after you are getting a output of both convolution and pooling layer, that is output of convolution and maximum pooling layer. Next I will convert this maximum pooling layer into vectorized form. Okay, in vectorized form. Okay, so after I am converting those vector form, what I will do means I will be connected with fully connected layers. Okay, for example you can see the picture. Those first neurons in my vector form, it will be connected with all the input, all the next hidden layer. Okay, that is called fully connected layers. Okay, so vector converting, after maximum pooling I am converting those vector into a fully connected layers. After that I will be split the data set what type of binary. Okay, so here the example picture is represent for birds. Okay, so but our data set is in the form of fashion articles. Okay, so likewise it will be changed. So fully connected layers is nothing but it involves weight, bias and neurons. So bias is used, how it should be calculated. The bias is using activation layer we can find the bias. Weight is nothing but each and every data have some matrix value, so that is called weight. Okay, so it connect the neurons one layer to the neurons to another layer, that is called fully layers. One layer will be connected to the all the neurons. Okay, another one second layers will be connected to another layer. Okay, so that is the called fully connected layer, and used to classify the category of training, image category, different category by training. Okay, and then softmax and logistic. Okay, so softmax and logistics, the final layer. Okay, final layer of the data set. So logistic is nothing but it will be called give the output binary classification, that is called if it is a output in the form of 0 or 1, you can use logistic layer. If it is the output of multi-layer classification, like now our data set in the form of multi-layer only, from 0 to 9 we have. Okay, so we want to use softmax. Okay, so totally we have an 2 layers at the final layer. One is logistic and softmax. If it is a binary type we can use logistic. If it is a multiple binary type, we can multiple classification, we can use softmax. Okay, so that is what we need to tell. Okay, so then output layer will be predict the output whether it's a 0, 1 or 2, predict the label. Okay, so label is nothing but 1 means trouser, 2 means t-shirt, like that we can predict the output. That is the output of output layer. Okay, so before we are going to the coding part, I need to just give the little bit introduction to Keras and Tensorflow. Okay, so Keras and Tensorflow is nothing but it's a package we are using to develop a neural network algorithms. Okay, whether it's a convolution neural network algorithm or RNN or DNN, any neural network algorithm, we need those packages, Keras and Tensorflow. Okay, so Tensorflow is nothing but if you are it's invented by Google. Okay, so it's like a multi-dimensional array. Okay, so Tensorflow is nothing but it's a multi-dimensional array. If you want to develop an neural network algorithm, you need this Tensorflow package as a backend. Okay, so Tensorflow is developed by C++. Okay, so Tensorflow is available for both CPU and GPU. According to your PC configuration, you can install for CPU or GPU, that's your wish only. Okay, then Keras is nothing but it's a API to build the neural network algorithm. Okay, so for example, we already told to you about TensorFlow. If you want to develop a neural network algorithm using this Keras API, we need to build the neural network algorithm. Okay, so Keras will be used for most of the smartphones like iOS, Android, and web machine and virtual machines and all. Okay, so then after that we will move on to real-time execution. Okay, how our TensorFlow and Keras will be using, how we can build the neural network algorithm, how we can build the convolution neural network algorithm. Okay, so for that purpose I am using an Jupyter notebook. So Jupyter notebook is one of the easiest tool to implement an deep learning algorithms. Okay, so here I am having, okay, so I already I have a code. Okay, because what is the thing is, here we need to, for convolution neural network, we need to use not an inbuilt data set, we need to use an CSV file, comma separated value. Okay, so using those CSV file, if you read the input data, it takes so much time to train the algorithm. Okay, so that is what I already trained the algorithm and I already tested the algorithm. I get an output. So I am just showing you the program, and then just I will tell the line by line explanation. Okay, but if you want to do for deep neural network, we can use it as a default data set. Using Keras, we can import the data set and we can train the algorithm. Those in the that should be done by before webinar itself. Okay, those webinar link will be uploaded after this webinar. Okay, you can just click those link and you can watch that video. I will be run the code using step by step. Okay, once you can check those videos. Okay, so CNN, okay, convolution neural network. So NumPy, here I am importing. NumPy is nothing but it's a linear algebra. To build a mathematical calculation or to build a numerical calculation, you can use NumPy. Okay, then pandas is nothing but to read the input data set. Okay, so my here I am using as a CSV file. Okay, to read the input data set. After that, reading the input data set, so I am having a train data and y train data, that is x train and y train, x test and y test. Okay, x train is nothing but 16,000 image. That 16,000 image will be stored in y train. Output will be stored in y train, that is 0 or 1 or 2, 3, like that. Okay, like same thing only x test image, that is tested image, that is 10,000 image. The 10,000 image data will be stored in y test. Okay, so if I get the shape of the x train, I am getting the shape 16,028 into 28 megapixel. Okay, that is the shape of the x train data. If I get a shape of the test data, I am getting a shape 10,028 into 28 megapixel. Okay, so this is what I want to tell to you. Okay, so I already told to you, here I am using an CSV file. I'm just showing you show the some of the data, okay, some of the output printing, sorry, some of the pictures I want to show you. After that I will be move on to coding file. Okay, so here you can see I am displaying the first row input data. Okay, in my train data I am giving a 0th index value. So at 0th index value I am having some data, those data in the form of 0 to 255 range black and 0 to 255 range grayscale value. Okay, 0 to 255 grayscale value. Okay, so this is the first index value out data. Okay, so we didn't get any we can't understand this. Okay, they have just a numerical value only displaying, but I need to know what is the exact data in those 0th index value. Means you can use this. Okay, so before that I am checking what is the 0th index value. 0th index value is I am getting an output in y train 9. 9 is nothing but, if you go to our dataset description, what is the 9? 9 is ankle boot. Okay, so we have an output ankle boot in y train. Okay, so just I am again showing the image using plot. Okay, plot is nothing but matplotlib. Okay, I am importing a matplotlib library file through plot. Okay, then after that I am showing that image, it's getting an output like this. So I am getting an output in my slide ankle boot. G9 is ankle boot, so like those ankle boot images only I am getting here also. Okay, so see here, it's a 28 into 28 megapixel, both x-axis and y-axis I am getting 25, 20, that is 28, 28. Okay, so now it's confirmed what are the data available in each index value. For those data I am getting an output in y train. Okay, now it's having. Okay, so now you will be get a somewhat clarification of our data set. Okay, so here I am just using a cmap function. I want to check, I want to just view into grayscale value, only grayscale image. So here you can see I am converting those thing into grayscale. Okay, so up to this I think you will be understand how we can how is our data set and how is our train data and how is our test data. Okay, so next we will move on to data set. Okay, so before that I need to tell to you, here I am reading my data set fashionminis.csv and train.csv and test.csv. so I am downloading those data in Kaggle website. Okay, so both for training and testing separately we have CSV is nothing but it's a Excel sheet only, normal Microsoft Excel or any other Office Excel. So comma separated value is one of the format. So I am using those data set, I am reading those data set using pandas. PD is nothing but pandas. I am save it in data train. Okay, and data test. Okay, so I am having a train data and test data. So after that here I am saving my 28 into 28 megapixel into rows and columns, and after that rows and columns I am reshaping those images, sorry, those data comma 1, that is 3D input shape is equal to 3 column. Okay, after I am doing this one, I am converting my data into a separate variable, that is I am having an fashionminis.train.csv. Okay, in those data set first column having an output, that is having a label. Okay, in second column to last column I am having an data. Okay, so like this will be applicable for this also. Okay, what I will do means I will take a first column into an, that is label column into an one variable, and then all the data into the another variable, that is label column is equal to x, and then last from second column to last column will be taken in, sorry, this should be in x and this should be in y. Okay, so that is label column will be take it as a y and last column will be 2 to last will be x. Okay, that is what here I am doing. See here. Okay, so using ilog function from starting to ending, but I need a data from 1 to 0, sorry, 1 to end of the index value. Okay, that is data from starting data to ending data. But here you can see using ilog function I am taking only a 0. Okay, 0 is nothing but label. So after I am splitting those dataset, I am dividing my dataset into validation. Okay, that is what I am doing means in train data I am splitting my dataset into x and x train value and x validation value. Why I am using this one means for checking whether my dataset is overfitted or underfitted, it's correctly fitted. Okay, so if you take machine learning or deep learning algorithm, if you during training time algorithm want to train properly. Okay, so if it is an overfitting means it's not overfitting, or underfitting means the dataset will be not in the balanced manner. Okay, we need to do the dataset in the balanced manner. Okay, so for that purpose we need to do some cross validation function. But here what I am doing means in trained data itself I am dividing my trained data and validation function. Okay, after that test I am reshaping my test I am taking in x and y. Okay, so after that what I am doing means I am reshaping the all trained data and test data and validation data. Okay, reshaping is nothing but I am converting my image columns and index values. Okay, so after that I am converting the data into the float. That is nothing but float function, converting my data into the float 32 type. Okay, after converting I am doing normalizing the data. Normalizing is nothing but we need to reduce the values, each values after converting into the float. It's have a huge number of values. We need to reduce those float values into the value. Okay, so after this here I am importing my data set, sorry, importing my libraries. Okay, so first I am using sequential. Okay, sequential is nothing but it's a model used to build a neural network or convolution neural network or RNN. Okay, so using that model I am importing the sequential model. After importing a sequential model I am importing a layers. Okay, layer is nothing but dense, dropout and flatten. Okay, so dense is nothing but neurons. Okay, dense is nothing but neurons. Okay, so then flatten is nothing but I already told to you we need to convert our matrix into vector form. Okay, so for that purpose I am using flatten. Okay, after that convolution 2D and maximum pooling 2D. Okay, so convolution 2D and maximum pooling 2D. Here you need to know what is convolution. So I already told you what is the use of convolution, and pooling also we can use. I already told to you what is the use of pooling. Okay, then normalization function. Okay, I am importing a batch normalization. Batch normalization is nothing but if you give a batch size equal to 10 or 20 or 256 or anything, each and every iteration is take that much batch. For example, if you give a 256 means each and every iteration 100% iteration, it will be take 256 batch number of images to train the algorithm. Okay, so here I am giving a batch size equal to 256 and number classes equal to 10 you already know what is the classes 0 to 9, so 10 classes. Then approaches equal to 50. So approaches means number of iteration. Okay, so approaches equal to 50 times it will be iterate itself. Okay, then what I am doing means I am importing I am calling the sequential function and save it in one model variable. Okay, so model is nothing but we need to build the neural network algorithm using those model only. Okay, so here I am adding in model I am adding convolution 2D. Okay, so convolution 2D is nothing but convolution layer. I am giving an input data 32 and kernel size equal to 3,3 activation is equal to relu. So this is the activation function I am using relu. And then kernel initializer equal to hc underscore normal, and input step I already given a input step here. Okay, you can see here I am giving input step. So using those input step, here you can call the input step. Okay, so after that, next one I am first, what is the layer of first layer in convolutional neural network? Convolution 2D. What is the next second layer? Maximum pooling. So I am importing a maximum pooling. Using those maximum pooling, I am using a dropout function and convolution 2D activation function. Okay, that is what, after I am done using maximum pooling, I will be get on new data. Then again I am passing those new data to the next convolution layer. Okay, so next convolution layer will be do some process using the relu activation function. Then it will be give again some data, that will be passed through to the maximum pooling. Then it will be sort the data. Okay, so like that I am using 3 times maximum pooling and convolution 2D, because I have a large amount of data. Okay, we need to using those large amount of neurons, I need to minimize those neurons as a output function from 0 to 10. Okay, so for that purpose I am using more number of maximum pooling method. Okay, so after I am done these all the thing, next one is flatten. Okay, about flatten we already know, converting those data into the vector form. Okay, so using those data into the vector form, that is I am passing a 128 layer, that is input data is 128. Okay, so between these I am passing input data 128, and after that number of classes is nothing but I already given number of classes equal to 10. Okay, so using 10, activation function is softmax. About softmax we already know, here I told to you. Okay, softmax is nothing but it's a multi-classification variable. Multi-classification is means we have a classification function from 0 to 9. Okay, so that is what here I am telling to you. So softmax I am using as a multi-classification layer. If it is a 0 or 1, that is true or false as my output, we can use the another one layer, that is okay. So next one, compile. Okay, so after I am creating those neurons, I need to compile those neurons with passing my input data. Okay, so I am using compile function. I am creating one neural convolution neural network linear convolution neural network model. After I am compile those model. Okay, so before that I am using summary function. It will be give the information about convolution 2D network and convolution maximum pooling network also. Okay, then after that, here you can see I am using model.fit xtrain and ytrain. So I am passing the train data to the model. Okay, so after I am passing the train data to the model will be started to train the started to learn, though using those data it started to learn. Okay, so using batch size equal to, I already told you batch size is nothing but each and every time iteration how much pictures want to learn by algorithm. Okay, above is nothing but 15 time iteration. And then validation data is nothing but I am passing x train data and y train data and x validation data and y validation data. Okay, then after that I am giving those, after I am training the data, I am giving only an x test and y test. Okay, x test and y test is nothing but I am passing my test data to the model, then I will be get the accuracy score. Okay, so here you can see I am having an FOS equal to 50. 50 is nothing but 1 divided by 50 means still we need to run up to 50 times. Okay, 50 times we need to run. Here you can see, here I am having I am run the program up to 35 times only, but up to 50 times we need to run. Okay, so between these I am having an two output, that is loss function and accuracy score. Okay, loss function is nothing but I am getting a low number of loss function. When you compare to the first loss function, here you can see my loss function is 0.8071, but if you get a more number of loss function, then your accuracy result will be less. Okay, if you are getting a less number of loss function, if you are getting a less number of loss function, your accuracy result will be improved. Okay, so that is why how we can get a less number of loss function means we need to improve the approach size with more number of times. For example, here I am just running for 35 times, so 35 times it is giving the accuracy result 92%. Okay, if it is a completed for 50, even more it will be increase the accuracy result. Okay, so here we are getting the result of loss function. Okay, so 0 and 1. Okay, so then I already told to you we need to check our data during training time. Our data should be in the form of correct manner, whether it should not be in what is that, it should not be in overfitting or underfitting. It want to fit correctly. Okay, so for that purpose I am using accuracy validation also, validation accuracy and normal accuracy also. Here we can see during training time I have some data, and during validation time also I am having some data. Okay, so if you see the graph, it's properly it's trained. Okay, both the training accuracy and validation accuracy also it's something proper manner only, not any changes. For example, validation of accuracy will be somewhere and training accuracy will be not in somewhere. Okay, both are in same path only. Okay, so now it's trained properly only. Okay, if you see the validation loss also, we can get an somewhat same thing only. Okay, so that is what I am telling. If you get an validation loss graph and training loss graph, or training and validation accuracy graph as a different path, okay, you are not trained your algorithm properly, whether it should be in the form of overfitting or underfitting. Okay, so that is the important thing. After that I am just passing the X test data to predict the output. After I am predict the output, I will be get an accuracy result. Okay, so here you can see I am using classification report from sklearn. Okay, sklearn is one of the package for machine learning type. So using those packages I am importing a classification report. In classification report I will be get totally 4. Okay, that is this one: precision, recall, F1 score and support. Okay, so precision is nothing but your true positive value and false positive value. That is machine predictor correctly it's a true, machine predictor correctly it's a false. That is precision value. Okay, when you are getting a false negative value, that is called recall. That is machine not predictor exactly, it's a shoe, it's a t-shirt, or it's a top, it's not predictor correctly. That is called false negative recall value. Okay, so F1 score is nothing but this both precision and recall multiply and add and divided by each other. Okay, then I will be get one output, that is called F1 score. Okay, so here you can see machine predicted correctly, that is it's a shoe, it's a chapel, then it's a like that, it's a 93%. Okay, machine, then recall function, recall is nothing but machine predictor something false negative value, that is 0.93. Okay, so this is what I have to tell to you. Here you can see some of the plotting, that is some of the correct values, first 10 correct values we can see. So my output value is in first row, first column, you can see predicted equal to 0 and class is equal to 0. Okay, that is what I want to tell. This is called precision value, that is it's predicted correctly. Okay, precision equal to 0 and predicted in test data my original output is 0 and my algorithm given output also 0 only. So that like this first 10 for predicted data. Okay, so if you are going to incorrect data as a first 9, you can see predicted data is 6, that is in first row first column machine predicted as a 6, but I am getting an output, my original output is 2. Okay, so that is what error is nothing but my recall function. Okay, recall function. Okay, so this is what we are doing with our convolutional neural network. Okay, so I hope this you will be understand those how to build a convolutional neural network. So it's something difficult to understand. Okay, so if you are know about neural network algorithm, that is artificial neural network algorithm, it is easy to implement a convolutional neural network algorithm. Okay, so that's why I am telling you to, after this webinar you just to go and check. I build an artificial neural network for same dataset only. Okay, once you check those videos, it will be useful for you and understandable for you. After those video, after you see this video, you will be come to analyze. Okay, this is what neural network algorithm and this is what CNN. Okay, this is the basic difference between CNN and neural network algorithm. You will be definitely, you will be understood. Okay, after this webinar I will definitely upload those link in description. Okay, so I hope this session will understand. If you have any question, you just ask me, I will be reply for you. So dataset is where to get the dataset from. Okay, dataset we are getting from in Keras package itself. Okay, if you need, you can import from defaultly Keras. Okay, so about certificate, you have to each and every time we will post in comment section itself, and we even pinned the certificate link also. You just to go through the comment section, means you will be get a link, and then using those link you can register your name for certificate. Okay, any other doubt? And one thing I have to tell to you, please subscribe our channel. We are new to this e-learning. Okay, if you are not new, we already have more number of 1000k videos in other channel also. This e-learning channel is a new. Okay, if you want to get a new videos like those, like this trending technology, you please subscribe the channel. Okay, and hit a bell icon. Okay, each and every time you will be get a notification if we post any video. Sure, you will be get some knowledge if you subscribe this channel, because each and every day we are posting different type of domain videos, both software related also, both hardware related also, up to the trending technology. Okay, so what is the difference between CNN and RNN? Okay, nothing but CNN is used to train the image. RNN is nothing but it's have a own memory. Okay, in recurrent neural network we have a own memory. Based on those memory, it will be give the output. But for CNN it's own there. Okay, any other? If you like this video, please hit a like button. If you are new to this channel, please subscribe this channel and hit a bell icon. Okay, any other? How can we give our convolution filters? Actually here I am using a default dataset only. Okay, so those default dataset we already have a filtered method. Using filtered only we have a trained the algorithm. But if you need filter wise anything you need, means I will take in further more webinar. I am using convolution neural network and I will be use some filtering methods and I will train the algorithm in real time. I am telling. Okay, those video I will upload definitely within few days. Okay, definitely using convolution neural network with filter method as our own dataset. Like for example, my image itself I will upload using as a dataset and I will train the thing. Okay, weather prediction using convolution neural network. Okay, definitely sure I will be. Okay, true positive and false positive is correct, and then false negative is recall. Okay, so that's what I need to tell you, that confusion matrix part will be somewhat confusing on each and every time. if I tell also you didn't get an exactly what is the meaning, okay, so you can just check it in websites or some other google it, okay, you will get an idea, because uh, always confusion matrix part will be confusing only. We will arrange the network engineers. Any other doubt? Yeah, about weather prediction using CNN, definitely, but it's not a good time. Sure, I will be uploading. Any other doubt? Scala is nothing but it's another one languages only. It's yeah, it's Python equal to Python only. Python, Java, Scala. It's always nowadays most useful language only. If you want to learn Scala, you can sure you can learn, not a problem. So if you are new to this channel, please subscribe the channel and hit a bell icon. You will be get a notification. Yeah, we can apply it for videos also, but what is the thing is, if you are in giving input data as a video also, I will be using filtering or using pre-processing. I will be take those video into an frame by frame only, that is picture by picture only. Why using Jupyter? Because if you are new to programming language or not a new, if you want to really want to study any machine learning part or deep learning part, or even any programming languages also, Jupyter notebook will be helps to learn easily when we compare to any other platform. Because before 3 years I also learned using Jupyter notebook only, okay. So that's why I'm using Jupyter notebook. Any other very useful session time? Yeah, sure, we will definitely upload the certificate, but you can use those links frequently. We are posting in comment section also, and we are pinned in comment section also. You just go and click those link and fill the your names and all for certificate. Definitely we will send the certificate to you, okay. Thank you for the clear sentence of yeah. Once I want to tell to this, if you want to use Tensorflow and Keras for your Python, you need to use 3.6 version. 3.6 you need to install 3.6 version. Otherwise, in Anaconda Navigator software, we have a option environment. Using those environment, you can create a new environment with 3.6 version, Python 3.6 version, and then you can install TensorFlow on Keras. That is pip install Keras and pip install TensorFlow. Then only it will be installed. Okay. Okay. So it's time to signing off. Okay. So any other doubt means you can see this. Okay. Any other doubt means thank you to one and all. Any other doubt, you can refer this mail to me, hod.java@pantechelearning.com. So thank you from Kamalesh. And then I have to tell to another one, if you are interested with doing any internship as a online internship for training, you can use this other domain we are covering for this quarantine. You can use, if you want to use this quarantine as a useful manner, you can study these are the internship domains we are offering to you, okay, for 1 month. Each day we have a 1 hour session. You can once go through this, and thank you to one and all. And then if you want to do for your college, or if you want to register for internship purpose, you can contact those 3 numbers. Okay, Mr. Sanjay Kumar, Mr. Srinivasan and Mr. Kumarasamy. Okay, you can contact those numbers and you can register for your both. If you want any webinar on any college related sponsor, you can contact those numbers, or if you want any certificate oriented or any other internship, you can contact those numbers. Okay, so thank you to one and all. We will see on next video. Okay, after this video I will give the description of the my simple neural network algorithm for this both for this fashion article dataset. Okay, once you check those videos also, it will be useful for you. Thank you for one and all to present here. Thank you to one and all. It's signing off from Kamalesh. Thank you.